Hello everyone. This is the third and last session of graph transformations. So in the first session we did the polynomial functions. The second one we looked at other types of functions like the square root. We didn't look at the cube root, but it's the same concept. Logarithmic, exponential, absolute value, and so on and so forth. And I told you the last time, meaning the third session, we will be concentrating on trig functions. So let's start by looking at the trig functions first, and then we can discuss how we are going to, transform these. Okay, so, oh my God, what's going on? The camera didn't pick up. Oh, I picked the wrong camera, I think. Okay, sorry for that. Alrighty, so let's look at the sine and the cosine, for example, graphs. So the x-axis here would be angles in radians, and the y would just be numeric. So if we look at, say, the sine graph, and all of you should know that, you get something, and excuse my drawing, it's gonna look something like that. The maximum value, of course, we know cosine or sine of pi over 2 is 1, and the negative here is sine 3 pi over 2 is negative 1. This point, we said the x is angle, so this angle is 0, this angle is pi over 2, this angle is pi, this angle right here is 3 pi over 2, and this angle is 2 pi. Once I reach 2 pi, the cycle repeats. So if I take the distance from 0 to 2 pi, I have a full cycle. I can also take it from pi over 2 to 5 pi over 2, right? It's the same distance. And this distance is called the period. So the period is the distance from any point on a sine graph to the corresponding point on the next cycle. Okay, so the period here is 2 pi. I start at 0 and at 2 pi, and then it repeats. So the period is 2 pi. The second thing I'm interested in is that distance right here, this height, which is going from 0 to 1, which is called the amplitude. So the amplitude is 1 for the sine curve. The cosine, so this is the sine. We draw it in pencil, so maybe I'll do the cosine along with it, sine of theta or x or whatever. The cosine starts at 1. So it's like I'm shifting the sine a distance of pi over 2. Just shift it, okay? And you should remember that. We said that sine theta is cosine pi over 2 minus theta. That's where it comes from. It's a shift. And this goes like that. Goes down to negative 1 here. Goes back to 0 at 3 pi over 2. And then to 1 again. Okay? And that's the cosine graph. It has the same period and it has the same amplitude. But what's cosine? We said theta, so cosine theta. Okay? Now, if I do the tangent, and this is the 0. We know that tan 0 is 0. This is pi over 2. This is negative pi over 2. And I know that tan pi over 4 is 1. So this point is 1. and negative pi over 4 would be -1. So this is -1. It's asymptotic with the y at -pi/2 and pi/2, and this cycle repeats. But now we see that this period going from -pi/2 to pi/2 is just pi. So the period is pi, and of course I don't have an amplitude. This thing goes from -infinity to +infinity. Okay, so let's talk about some stuff. Remember, we talked about displacement. Displacement can happen in the x or the y, as we've seen in the previous functions. But here, when we have displacement in the y, we are going to call it vertical displacement, okay? If we have a displacement in the x, we can still call it horizontal displacement, but because these functions are used a lot in engineering, especially in electrical engineering, we call it a phase shift. So if you join engineering and become an electrical engineer, you will better understand the meaning of the phase shift. Okay, so phase shift here is the same as horizontal displacement. Like we said in the, say, regular functions like polynomial, we say, okay, the graph will move 4 units to the right or 4 units to the left. Here I can say if the phase shift is positive, it may move an angle of, say, pi/3 or -pi/2, and so on and so forth. So we are going to talk in terms of angles instead of numbers. Also, the y stretching or shrinking will affect the amplitude, right? Because if I inflate that, 1 can become 3 or it can become 0.5. So that would be in the y, it's just affecting the amplitude. In the x, it would affect the period. It would be longer period or shorter period if I shrink or stretch. And finally, the change of sign is the same. Change of sign in the x, rotating about the y-axis, and notice if I do that to the cosine, it doesn't make any difference. Why? Because if you remember correctly, the cosine is an even function. So if I rotate about the y, a cosine curve, it stays the same. But if I turn it about the x, then this one would become -1 and this -1 would become 1, and it would be an inverted function. We'll see all of that. So I'm going to try to take some examples. So let's say take an example in sine, for example. So example 1, suppose I have y equals 2 sine, and then I'm going to say maybe I want to take more than 1 theta, so I don't want it to. So let's say what should I say? 3 theta minus pi/2, for example. I know, like when you study this at school, they give you a formula, A is the amplitude and whatever. We are going to use the same logic we had before. Notice that the parent function is y equals sine theta. So I only have sine of something on the right, which is this piece. So all what I have to do here is to divide by 2. So I'm going to say y over 2, so dividing both sides by 2, will give me sine 3 theta minus pi/2. Here you have an advantage over the student who memorized a specific form. How? If I look at the x, I can say add pi/2, meaning have a phase shift of pi/2 and then divide by 3. And someone else would say, can't I take a common denominator of 2? Absolutely you can. Absolutely. So we have two ways to do it. You can either make a phase shift of pi over 2 and then shrink the whole thing by 3, or I could have said this is sine 6 theta minus pi so I can here do the following. I can like stretch by x by factor of 2 and then have a phase shift of pi and then shrink by 6. In fact, there is a third, maybe better way to do it. A better way to do it. And that one, in that one, I'm going to say, no, I want this to be just theta. So I'm going to say sine, take a factor of 3 out, and that would be theta minus pi over 6. And say, oh, I'm going to divide by 3, meaning shrink the period by a factor of 3, then have a phase shift of pi over 6. See how many ways you can do it? And if you try each one on your free time, do it this way, do it that way, and see if you get the same graph. In fact, we can use a calculator and plot all three, and definitely, because the math is correct, you will end up with the same exact thing. I would say, just to be consistent with what you learn at school, I'm going to use the last one. So I will always start by writing the sine or the cosine or even the tan with theta by itself. So if theta is multiplied by something, I'm gonna factor it out. But these two are also correct. So you can do it I can describe it in 3 different ways, but because the books usually that you use in school use this approach, because they have the formula that A times sine or cosine of B, theta plus or minus C, and then plus D, and you have to memorize what each one is. Here you don't have to memorize anything. But because we are doing this, I'm going to use the third approach. So if we discuss, first of all, we already have the sine graph, okay? And if you want, you can pick the angles that you know. So you can say for the parent function x and y, if x is 0, y is 0. If x is pi over 6, this is 1/2. If x is pi over 4, this is root 2 over 2. If pi over 3, you get root 3 over 2. If it's pi over 2, you get 1. And then backwards, so, 2 pi over 3, you still get root 3 over 2. 3 pi over 4, you get root 2 over 2. 5 pi over 6, you get 1/2. And pi, you get 0. Let's see what happens here to the graph, and this time I will have to be very careful. Let me use the x on the left and y on the right like we did here. So what happens to the x? Number 1, I'm going to divide by 3. Divide by 3, which means shrink by a factor of 3. So just shrink, we know that. And then finally we add pi over 6, and that's the phase shift. That's it, right? Now if I go to the left hand side, which is the y, I multiply by 2, so stretch, so we say times 2, and the description is that stretch by a factor of 2. Okay, let's now apply these here. The y is easy, I'm just going to multiply by 2. So the 0 stays 0, 1/2 becomes 1. This is root 2, this is root 3, This is 2 root 3 root 2 1 0. But what happens to the x? I divided x by 3, 0 by 3 is 0, and then I added pi over 6, so this is pi over 6. It's a phase shift, as you can see. Divide by 3, you get pi over 18, and then add pi over 6, which is 3 pi over 18, you get 4 pi over 18, or 2 pi over 9. Divide by 3, pi over 12, and then add 2 pi over 12, you get 3 pi over 12, or pi over 4. Divide by 3, pi over 9 plus pi over 6, you take 5 pi over 18. Pi over 2 becomes pi over 6 plus pi over 6 is pi over 3. And if you repeat and come here, you get pi over 3 plus pi over 6 is pi over 2. Let's do the other 3, it doesn't matter. Divide this by 3, you get 4 pi over 9, or 8 over 18 plus 3 over 18 is 11 pi over 18. Divide by 3, get pi over 4 plus pi over 6. Okay, so over 12 you get 5 pi over 12. When it's 1, you divide by 3, pi over 3. Oh, this is pi over, I'm sorry, this is 5 pi over 6. You divide that, you get 5 pi over 18 plus 3 is 8 over 18, or 4 pi over 9. I hope I did it quickly, but not incorrectly. So, some stuff. We multiply this by 2. So, we had the amplitude, the new amplitude becomes 2. We didn't move the graph up or down, so the center line stays at 0. It's the same center line as this one. The original period was 2 pi. Here we divided, we shrank it by 3, so it becomes 2 pi over 3. So the period is 2 pi over 3. Phase shift, meaning where do I start drawing the sine? Where I start at 0 is pi over 6. And finally, maximum is 1 and minimum is -1. So let me get another piece of paper and show you an easy way to do that. So here is my new graph. I start at pi over 6. So I'm going to say this point is pi over 6. And the length or the period is 2 pi over 3, meaning 4 pi over 6. Pi over 6 plus 4 pi over 6 is 5 pi over 6. Let's say this is 1 pi over 6, 2, 3, 4, 5. So this point is 5 pi over 6. That distance is 4 pi over 6, right? 2 pi over 3, but 4 pi over 6. So I need, since I divided this period into 4 equal parts, so I know where is the maximum, where is the minimum, where is the 0, I'm going to do the same thing. So this is 2 pi over 6, or if you want, you can write it pi over 3. This is 3 pi over 6, or you can write it pi over 2. This is 4 pi over 6, or 2 pi over 3. And finally, 5 pi over 6. I'm going to start here. Notice the amplitude is 2. So the maximum, instead of being, say, I'm going to say this is 1, this is 2, this is -1, this is -2. So I'm going to reach the maximum and then go back to 0 and then reach the minimum and then go back to 0. And that is my function. I did 3 things. I stretched by 2, so the height here is 2. and the minimum here, the trough is at -2. I shrank the 2 pi into by a factor of 3, and I shifted by pi over 6. Now let's plot these together and see what's going on. I already changed the mode into radian. Let's plot sine x, and we said what it is. Okay, 2 sine 3x minus pi over 2. Oh, we didn't add those. If we had added, then we moved the y. I should have added something. Okay, let's graph. This is my original graph. That's the parent function. And this is this graph. You see, it's higher. And if I want to go to the table, oh, the table is not in. So it's better to go to calc. Let's pick pi over 2 here is 0, pi over 2 here is 1. So let's say value of pi over 2. It tells you 1 for the first graph and 0 for the second. Let's pick pi over 3. I know that at pi over 3, here it's 2, and here it was root 3 over 2, which is roughly 0.866. So let's check that, and then we move to another thing. Pi over 3. 0.866, which is root 3 over 2. If I move down, I should get 2. Yes, I got 2. So you see, it's the same exact work we did before, except here the nomenclatures are different. Instead of saying stretching the y, we say we stretch the amplitude or we shrink it. Instead of saying we translate horizontally, we say it's a phase shift. Instead of saying we shrank x or stretched x, we said we shrank the period or we stretched the period. Okay, let's take another example with maybe cosine this time. Oh my god, this was like the bullet. Oh my, I lost the, oh, it's okay. That's weird. I'm glad it didn't hit me. Okay, example 2. Let's take a cosine. So y equal cosine, let's say theta over 4 minus pi over 2, and maybe this time we say minus a number. Okay, so again, my parent function is y equals cosine of x. So only the cosine should be on the right hand side. Let's look at the left hand side. Again, I only need this part. So I'm going to add 2 to both sides. So that would be y plus 2 equals cosine of theta over 4 minus pi over 2. Remember, we said to be consistent with your textbooks, I'm going to take the 1/4 as a factor it out. So I'm going to write this equals cosine. Notice it's not necessary. You can describe it in many ways, but so that, you know, the method that they use is different from what I'm showing you here. I'm showing this to you so you can see what the translation means, what dilation means, what's reflection means, and so on and so forth. Instead of having a very rigorous way of doing it, and then a few years down the road you would say, oh my god, I can't remember, is it plus, does it mean up or down, is it right or left, because they treat the x different than the y, as you might have already experienced. But here, just to be consistent for the time being with your school, I'm going to say this is 1/4 and this would be theta. Notice that this is 2 pi over 4, so minus 2 pi. That's it. Notice I could have left it like that and say, oh, I have a phase shift of pi over 2, and then my I shrank the period by a factor of 4. Here, I'm sorry, not shrank it, extended, right? Because now we are going to say, how do I return this to be that? Here is the x, here is the y. First of all, you have to multiply by 4, meaning stretch. Stretch meaning, remember, our period was 2 pi. If I stretch it by a factor of 4, it becomes 8 pi. Then I'm going to add 2 pi. 2 pi is a whole period, so really it's as if I didn't do anything. I'm starting from 2 pi. Oh no, it means because the period is no longer 2 pi. I'm sorry. So we have a phase shift of 2 pi, positive 2 pi. As for the y, I didn't do anything except subtracting 2, meaning my center line, instead of being the 0, it became negative 2. I know that here is the cosine, the parent function, x and y. X is 0, I get 1. X is pi over 6, I get root 3 over 2. Pi over 4, root 2 over 2. Pi over 3, it's 1/2. Pi over 2 is 0, and then they go backwards, so 2 pi over 3 is negative 1/2 because the cosine function is negative in the second quadrant. 3 pi over 4, you get negative root 2 over 2. 5 pi over 6, you get negative root 3 over 2. And pi, you get negative 1. Y is very easy, just subtract 2. So negative 1. Root 3 over 2 minus 2, which is a negative number. Root 2 over 2 minus 2. 1/2 minus 2. 0 minus 2. Negative 1/2 minus 2. Negative 2 minus root 2 over 2. Negative 2 minus root 3 over 2. Negative 3. Okay, so the center line, instead of let's do the x. We haven't done the x. So multiply by 4, still 0. Add 2 pi, it becomes 2 pi. Multiply by 4, you get 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. Multiply by 4, you get pi plus 2 pi is 3 pi. Multiply by 4, you get 4 pi over 3 plus 6 pi over 3, you get 10 pi over 3. Notice they increase by, well, depends because I don't use the same thing. 2 pi plus 2 pi is 4 pi. 8 over 3 plus 6 over 3 is 14 pi over 3. 3 pi plus 2 pi is 5 pi. 5 pi, so 5 pi over 3 plus 6 pi over 3. Oh, wait a second, I'm sorry. 20, so 10 pi over 3 plus 6 pi over 3 is 16 pi over 3. And then finally 4 pi plus 2 pi is 6 pi. Yeah, something is wrong, right? Something. Oh, no, so it's not wrong. I thought I did till 2 pi and I said this distance should be 8 pi. No, that's correct. I'm sorry. So let's do the or let's plot this graph. So again, we start at 2 pi. Remember, we had a and it's 8 pi, so altogether I have 10 pi, so 4, 6, 8, 10. This is 10 pi if we are going to draw it to a smaller scale, so I don't want to go very far or outside the paper. I'm going to divide that by, that's a distance of 8 pi. You have to divide by 4 parts because you go to up, down, 0, down, 0. Or, so I have 4 pi, 6 pi, and 8 pi. This line is -2. Or if you want to make that the 0, so I will draw the center line. Let's take it 1, 2. So here is the center line. We didn't stretch the y, so the amplitude is still 1. If I start at -2, the maximum would be at -1 and the minimum would be at -3. Okay, so this line is the max and this line is the min. At 2 pi I start at -1, which is the maximum, right? I start at the maximum, then I go to 0, then to -1, then to 0, -3, then to 0, then to -1. So my graph would look something like that. And again, oh my god, I think it's the, oh, am I losing? What's going on? The power pack? No, it's connected. Why did it do that? It's 100%. Why did it dim? I'm sorry guys, what I did is that I went from a maximum of -1 to a minimum of -3. I start at 2 pi and at 10 pi because my period is 8 pi. So the amplitude is still 1. Center line became -2 because I went down 2. And the period is 8 pi and the phase shift is 2 pi. So I start at 2 pi and I end at 10 pi. Period is 8. We divide the period into 4 pieces because we go from maximum to middle to minimum to middle to maximum to complete a whole cycle or period. Okay, so now let's clear that. This one is cosine x, and this one we said is cosine x over 4 minus pi over 2 minus 2. This is the cosine graph. I drew like that. You see how long it is? So let's go back to the window and say x minimum, we start at really 0, it's fine. We end up at 10 pi, right? Yeah. So let's do this 10 pi, and then you can go from -5 to, well, we are from -3. So let's make this is, we can leave it and we can make that 0. So it would be, oh, 0 will not show this. Okay, it's okay. But here you go. You see one whole period at 10, from 0 to 10, we did 10 pi. If you go to the table, or instead of the table, if we pick a couple of values, do you have anything? Well, we can do, say, 10 pi over 3. 10 pi over 3. It's 1/2 here, but for the other one, it's -1.5. Yes, negative 3/2. Let's pick another one, 16 pi over 3. This is 0.866, so negative 2.866 I should get, right? If I say 16 pi over 3, negative 2.866 as we expected. So the numbers are correct. The graph is very easily done, and the changes are as described. We didn't do a tangent, but it's the same thing. The only difference is that the period is only pi, not 2 pi. So if you're gonna shrink it or stretch it, just make sure it's pi, not 2 pi. I hope this was easy enough for you to follow, and if you have any questions, as I always say, leave me a note in the comments and I will get back to you as soon as I can. Thank you very much for your time. Sorry it was a little long because you know, sine and cosine are a little more not complicated, but I would say the involvement here is higher. So I hope you liked it. Thank you very much for your time and hope to see you soon.